I want you to think back to, like, the very last time you were completely and just hopelessly glued to a suspenseful movie. You know that exact feeling, right?
Yeah. White-knuckling the armrest for sure.
Exactly. The rest of your living room just sort of like evaporates and you are entirely locked into the screen. Or honestly, maybe it's not a movie for you. Maybe it's 2 in the morning. The glow of your phone is just burning your retinas and you are falling down this massive rabbit hole of online argument.
Just completely unable to look away from the drama.
Right. We have all been there. But what if that irresistible pull you feel wasn't just, a personality quirk or some lack of self-control?
Hmm.
What if that feeling is actually a highly specific, totally predictable biological mechanism? And, I mean, more importantly, what if militaries and state actors are actively trying to map, control, and, like, weaponize that exact feeling to change how the world thinks?
I mean, it sounds like something straight out of a cyberpunk novel, honestly. But the data we're looking at today puts this squarely in reality. We are stepping into this space where human neurobiology directly collides with global information warfare.
And that collision is our mission for today's deep dive.
Hmm.
We're exploring the actual science of narratives. And we're going to start microscopically small, literally inside the synapses of the human brain, just to see the biology of storytelling.
Right.
Then we're going to zoom way out to see how bad actors manipulate those exact biological levers to kind of flood the zone and hijack global information networks.
It's a huge shift in scale.
It is. And our stack of sources today is just wild. We have official program summaries from the Pentagon's research arm, DARPA. We've got a BBC feature on the neurobiology of violence, this independent Substack analysis of cognitive manipulation, and a really dense, brilliant doctoral dissertation that maps out social media influence during a massive disinformation campaign.
It is a phenomenal stack of sources, really,
Yeah.
because it forces us to connect two things that we almost always treat as totally separate. The chemical hormones in your bloodstream and the trending topics on your social media feed.
Yeah.
They are intimately connected.
So let's start with the brain. Back in the early 2010s, DARPA launched something called the Narrative Networks Project, or N2 for short. The goal there was to figure out exactly how narratives influence human thoughts and behavior.
And they were looking at this entirely from a national security perspective, right? Trying to understand the root causes of radicalization, insurgency, and terrorism.
Exactly. So, okay, let's unpack this, because the underlying premise of the N2 project is pretty stark.
It is. They basically hypothesized that stories aren't just passive entertainment. A story exerts a physical, measurable force on the human mind. And one of the key researchers funded by this DARPA program was Paul Zak. He's a neuroeconomist.
Right.
And Zak wanted to measure how stories physically alter our brain chemistry.
Right.
Specifically, he was looking at oxytocin.
The trust hormone. But, I mean, I'm naturally a bit skeptical of this kind of thing. How do you actually measure something as abstract as trust from a story? Like, are we just talking about a placebo effect where people feel warm and fuzzy?
It's a totally fair question.
Yeah.
And it's actually why Zak's methodology had to be so incredibly rigid. He didn't just ask people how they felt after hearing a story.
Because self-reporting is flawed.
Exactly. People lie, or they just don't know.
Yeah.
He ran an experiment where university students watched a short, highly emotional video. It was a father describing his young son's battle with terminal brain cancer.
Oh, wow. That is heavy.
It's a gut-wrenching narrative. But to measure the actual biological effect, Zak's team actually placed IV lines in the students' arms.
Wait, they hooked them up to IVs?
Yeah, literally drew their blood immediately before and immediately after the video just to track the literal spike in oxytocin molecules.
Okay, that is intense. So you have the hard chemical data, but a chemical spike doesn't automatically equal, like, actual trust in the real world, right?
Right, which is exactly why they added a behavioral component to the study. So they paid the students for participating in the experiment, and after the video, they gave the students a choice. They said, keep the cash or donate some of it to a childhood cancer charity.
Oh, I see where this is going.
Yeah. The findings were undeniable. The blood work showed the narrative directly triggered a massive release of oxytocin, and the higher the oxytocin spike in the blood, the more of their own hard-earned money the students just gave away.
That is wild.
The story didn't just make them sad. It measurably altered their neurochemistry to compel generous, trusting behavior.
That is fascinating. But I mean, it also feels a little wholesome for a DARPA security project, doesn't it?
Yeah.
Empathy and charity are great, but DARPA is usually focused on, threats. Which I guess brings us to Eric Schumacher's MRI studies at Georgia Tech. They were looking at fear and suspense.
Exactly. They were looking at the mechanical limits of human attention. So Schumacher's team put undergraduates into functional MRI machines. And if you aren't familiar, an fMRI measures brain activity by detecting changes associated with blood flow.
Right.
So when an area of the brain is more active, it consumes more oxygen, and blood flow to that specific area increases.
So you can literally watch the brain light up in real time on a monitor.
Precisely. So they had these students watch 3-minute clips from highly suspenseful movies. We're talking classic Alfred Hitchcock films,
Mhm.
as well as like tense scenes from Alien, Misery, and Cliffhanger.
Good choices.
Yeah. And the researchers were specifically looking for what happens biologically when a character is facing a looming potential negative outcome.
The suspense.
Yeah.
And the results of this study are what really stuck with me, because they found what Schumacher called the neural signature of tunnel vision.
Mm-hmm.
Basically, as the suspense in the movie ramped up, the fMRI scans showed that the brain activity associated with processing the viewer's peripheral vision just fell off a cliff.
It completely shut down. And what's wild is that it wasn't just visual. Their ability to perform a secondary unrelated task in this specific case, they were supposed to press a button when they heard a specific tone through headphones. That ability dropped significantly.
Wait, I want to make sure I'm wrapping my head around this. If suspense literally gives us biological tunnel vision, doesn't that mean a scary enough story makes us functionally blind and deaf to outside facts?
It absolutely does. And what's fascinating here is, well, you have to look at the evolutionary logic behind why our brains even do this.
Okay, why?
When you are processing a looming emotional threat, which is, the textbook definition of suspense, your biology literally forces you to drop your focus on the surrounding environment. Think about our ancestors.
Right.
If you were being hunted by a predator in the tall grass, your brain doesn't want you distracted by the pretty flowers in your peripheral vision. And it definitely doesn't want you trying to multitask.
That makes total sense.
Yeah, it diverts all your cognitive resources to the immediate threat.
So when a narrative on a screen or a feed triggers that exact same primal threat response, we become highly susceptible to the story right in front of us. We literally can't see the broader context because our brain thinks we're about to be eaten.
Exactly. The narrative is hijacking a basic survival mechanism.
Mm-hmm.
But the thing is, it doesn't just dictate what you pay attention to in the moment. The research shows this biology also dictates who you care about, which, really bleeds into our deepest held beliefs.
Let's get into that. Because if you can map how the brain processes a Hollywood thriller, the natural next step is seeing if you can map how the brain processes our core identities. Which brings up the Emory University professor Greg Burns.
Yes, his work is incredible.
He did an fMRI experiment where he actually offered to pay people to sell out their fundamental ideals.
Right. He was testing the biological boundary between, trivial preferences and what sociologists call sacred values.
Right.
So a trivial preference would be, preferring a Mac over a PC, or maybe liking one sports team over another.
My loyalty to my sports team feels pretty sacred, especially during the playoffs.
Fair enough, fair enough.
But I hear you. He's talking about deep moral or political convictions, things you wouldn't normally compromise on.
Right. And he found that the brain processes a trivial preference and a sacred value in completely different regions. So trivial choices, they light up the brain's reward centers. It's basically a simple cost-benefit analysis.
Makes sense.
But when he asked them to sign a paper contradicting a sacred value, like their stance on fundamental human rights for cash, the reward center was completely quiet. Instead, a region associated with evaluating abstract right and wrong lit up.
Which is logical, but honestly, the study that really threw me for a loop was the one out of MIT by Dr. Emile Bruneau. He was looking at empathy specifically within the Arab-Israeli conflict.
Oh, this is a landmark study. It really is. Dr. Bruneau had Jewish Israelis and Arabs read stories while they were inside an fMRI scanner. And these stories were specifically designed to evoke sympathy about members of the other group.
Right, so they were reading these tragic personal accounts of physical or emotional pain suffered by the quote-unquote enemy.
Exactly.
And the fMRI scans showed that reading stories of suffering about the opposing group actually activated the sympathy region of the brain, the medial prefrontal cortex, just as much as reading about their own group. Honestly, I read that part and thought, wow, there's hope for humanity. Biologically, we are actually wired to feel the pain of our enemies.
I mean, it is a very optimistic finding on the surface.
Mm-hmm.
But you have to look at the control group in that study, which is where things take a very strange, very dark turn.
Yeah.
When those same participants read the exact same types of tragic stories, but about people from South America. So a group totally geographically and politically disconnected from their specific conflict. The response in that sympathy region was noticeably muted.
It barely registered at all,
Yeah.
which leads to that incredible insight from the study. The opposite of love isn't hate, it's indifference. The fact that the Israelis and Arabs were in a bitter conflict meant they were intensely engaged with each other. They cared, even if it was completely adversarial. But the South American stories didn't trigger empathy because the brain just sort of defaulted to indifference. Why does it do that?
It's entirely about cognitive load. The human brain simply does not have the caloric or the emotional bandwidth to care deeply about every single tragedy on the planet. Empathy is biologically expensive, if you think about it.
Oh, that's an interesting way to phrase it. Expensive.
It is. So we reserve it for the people we are actively engaged with, our family, our tribe, or, as the data shows, even our direct enemies. For an outgroup that doesn't impact our survival at all, the brain just saves energy by remaining completely indifferent.
Which brings up a massive ethical dilemma. I mean, if we can put someone in an MRI machine and literally map out their empathy, their indifference, and their sacred values, where is the line between trying to just understand human conflict and straight-up brainwashing?
This raises an important question, and it's the exact ethical cliff edge that the sources highlight. The psychologist Tom Pichinski actually compares this potential to the dystopian novel A Clockwork Orange.
Right, where the state forcibly conditions a violent criminal to feel physically ill at the mere thought of violence.
Exactly.
Yeah.
So Pichinski asks the real-world equivalent of that. If we actually have the technology to neurologically alter someone so they can no longer hold violent, radical beliefs, do we do it?
It's a huge question.
Right. You might save lives, but you are effectively eradicating their free will.
And before anyone says that's just sci-fi, I mean, the Substack analysis we read by Annie Sumo specifically points out that this technology exists right now, today. She talks about the dual-use nature of mapping these neural pathways.
Yeah. Sumo brings up transcranial magnetic stimulation, or TMS.
Okay, I have to stop you there. Mind control magnets. Explain how that actually works, because it sounds completely unhinged to me.
I know it sounds wild, but it's really just grounded in basic physics.
Yeah.
Faraday's law of induction.
So your brain runs on electrical impulses, right?
Right.
Well, TMS uses a magnetic coil placed near the scalp to deliver rapid magnetic pulses. These pulses pass right through the skull and induce tiny, localized electrical currents in specific targeted regions of brain tissue.
Wow.
And by doing this, you can essentially silence or activate specific neurons. It is actually currently used as a legitimate medical treatment for severe depression.
But Sumo's point in the analysis is that an authoritarian regime could theoretically use something like TMS, or even just highly tailored neuropropaganda, to physically suppress the part of the brain that holds sacred political values.
Yeah.
Like, they wouldn't even need to argue with dissidents. They could just short-circuit the dissent at a biological level.
Exactly. Or, on a more mundane but honestly still invasive level, imagine a corporation exploiting these vulnerabilities. If a marketing firm knows the exact narrative structure required to decrease your peripheral vision and spike your dopamine, they bypass your critical thinking entirely. All right, so we've pretty well established that on an individual level, if you have the right story, you can practically hack the human brain. But a story in a vacuum doesn't change the world. It has to travel. So let's transition from the individual brain and lab to the global nervous system of the internet.
Okay.
How do these biological triggers actually spread across millions of people?
To map that out, we have to look at another DARPA initiative. This one is called Modeling Influence Pathways, or MIPs.
MIPs, right.
The goal of MIPs is to use artificial intelligence to track how a coordinated influence campaign flows across the modern information ecosystem. They basically want to see the exact path a narrative takes from, say, a fringe anonymous message board all the way up to a primetime news broadcast.
And the sources gave a really stark historical comparison to show why this AI is even necessary. Back in the 1980s, there was this massive disinformation campaign claiming the AIDS virus was a manufactured bioweapon. To track how that specific lie spread, analysts had to literally sit in rooms with physical newspapers, manually tracing the citations from fringe newsletters to mainstream outlets. It took years. But today, try doing that with a COVID-19 narrative.
You just can't. The pathways are way too dense, and the speed of transmission is basically instantaneous. You need AI just to visualize the battlefield.
Yeah.
And that battlefield is often dominated by a very specific tactic, which is actually the focus of Jasser's doctoral dissertation in our stack.
Right. Jasser provides a really rigorous academic analysis of a strategy called flooding the zone, or FTZ. And just a quick note for the listener, we're looking at this purely as a mathematical study of network topology and media tactics. Jasser uses the Skripal poisoning incident as his primary case study, mapping exactly how different state actors propagated information during that specific event.
And the Scrapple incident is a perfect data set for this, because it involved a massive sudden injection of conflicting narratives over a very short period. And this flooding the zone strategy, it completely flips the traditional script on propaganda.
This is the part that really changed how I view my own social media feeds. Like, we usually think of propaganda as the singular, beautifully crafted lie that they really want you to believe.
Right, the silver bullet.
Exactly. But FTZ isn't about convincing you of one thing at all. It's more like a bad actor walking up to your table and just dumping a million puzzle pieces from 5 completely different puzzles right in front of you.
That's a great way to put it.
They don't actually care if you build a specific picture. They just want you to get so totally exhausted and frustrated sifting through the pieces that you give up trying to find the truth at all.
If we connect this to the bigger picture, it is fundamentally a strategy of exhaustion. According to Jasser's data analysis of Twitter and Facebook during the Skripal incident, outlets like RT and Sputnik weren't even trying to win a logical debate.
They didn't need to.
Right. They were generating an overwhelming volume of content. The data showed they had the highest number of posts and shares by far, completely eclipsing major Western news organizations just through sheer quantity alone.
Because volume creates the illusion of consensus. If I see 50 articles about something, even if they are low quality or from weird sites, my brain automatically assumes there must be a fire where there's that much smoke.
Exactly. By flooding the space with contradictory articles, alternative theories, and just straight half-truths, they heavily muddy the waters. It becomes incredibly burdensome for an average person to verify the facts. So they sow confusion, and in doing so, they create these insulated echo chambers where entirely different realities can exist simultaneously.
But throwing a million puzzle pieces on the table only works if people are actually willing to pick them up and show them to their friends. You can't just bot your way to mainstream influence, right? So how do these specific narratives actually win the war for real human attention? Who is spreading them?
That is the core question of the dissertation, and Jasser answers it by using some incredibly advanced metrics. He doesn't just look at simple retweets. He uses a metric called transfer entropy.
Okay, transfer entropy.
Yeah, which actually calculates the literal probability that information flowing from user A caused a change in behavior in user B. And then he pairs this with something called the edge knockout model, or EKM.
I really want to dig into the EKM because this sounds like something a structural engineer would do, not a media analyst.
It is essentially a structural engineering, just applied to data. So in a social network graph, users are called nodes, and their interactions are the edges connecting them.
Okay.
The edge knockout model takes massive computational power to simulate what happens if you systematically delete specific connections or edges between users. It's exactly like removing load-bearing walls in a virtual house just to see which ones cause the roof to collapse. It tests who is actually a vital source of an idea and who is just a passive consumer.
And the data from this knockout model revealed a massive shocker. When they mapped the true influence pathways, the foreign media outlets, the ones generating all that massive volume we just talked about, they were not the main drivers of influence within the network.
I know, it seems completely counterintuitive. The architects of the campaign aren't actually the ones driving the influence. The analysis showed that these foreign entities heavily targeted and relied upon local influencers. In this Skripal case study, it was British users.
Wow.
The foreign outlets supplied the narratives, yeah, but they absolutely needed the local users to legitimize it.
Because a local user has built-in trust with their audience, it's almost like, I don't know, the foreign actors are just quietly handing matches to the most controversial people they can find in a really dry forest.
That analogy is exactly what the data supports. And Jasser proves this when his research pivots to analyze a massive Reddit dataset. He really wanted to understand the role of controversy itself in making these cascades go viral.
And they analyzed millions of comments for this, didn't they?
Millions.
It turns out controversial information doesn't just spread a little faster, it fundamentally alters the physics of the network. It spreads significantly faster and much, much further than non-controversial information.
Controversy is the rocket fuel. The research demonstrated that if you take a standard narrative and inject highly controversial, polarizing elements into it, for example, comparing a current event to the Iraq WMD's intelligence failure, or, citing the highly divisive Steele dossier, The lifespan of that narrative cascades just explodes.
And the people posting that highly charged content aren't just random users on the fringes of the internet.
No, not at all. The network analysis showed that controversial authors naturally gravitate to what graph theorists call the K-core of the network.
The K-core.
Yeah, the K-core is the absolute most densely connected center of an online community. Think of it as the downtown hub of a city. The most controversial voices aren't outcasts. Structurally, they are the glue holding the entire influence network together.
Which brings us all the way back to the beginning, doesn't it? To the biology of the brain. Why does controversy work so incredibly well? Why is it the rocket fuel?
Because it triggers that exact emotional threat response we talked about with the Hitchcock movies.
Exactly. Controversy creates suspense, it creates outrage, it forces your peripheral vision to drop, it spikes your neurochemistry, and it practically guarantees that you will stop whatever you are doing, focus entirely on the perceived threat, and share it with your network. The bad actors aren't just hacking a social media algorithm, they are hacking our evolutionary biology to make us build the echo chambers for them.
It is a perfectly closed loop. Your neurobiology dictates what you pay attention to, and the network topology dictates how fast that attention can be scaled globally. When you combine the findings of DARPA's Narrative Networks project with the flooding the zone tactics, you realize that the global information space is being actively engineered to exploit human biological reflexes.
So as we wrap up today's deep dive, I want you, the listener, to really keep this in mind next time you are scrolling through your feed late at night. The information you consume isn't just passive data lighting up a screen, it is a highly calculated biological trigger. Your neurochemistry can be reliably hacked by a good story, and your social networks can be easily overwhelmed by manufactured controversy. You aren't just an audience member anymore. Biologically speaking, you are the battlefield.
And that leaves us with a deeply unsettling thought to take away. We know from these sources that DARPA and other organizations are building AI to track these influence pathways.
Yeah.
But we also see how fast generative AI is advancing in the real world.
Oh, yeah, fast.
So what happens when machines are tasked not just with tracking these cascades, but with actually creating the narratives themselves? If an artificial intelligence knows the exact combination of words, images, and timing required to decrease your peripheral vision, spike your oxytocin, and totally bypass your critical thinking, how will you ever know if your beliefs are truly your own?
That is a question that is definitely going to keep me up tonight. Thank you for joining us on this exploration of the mind, the media, and the hidden mechanics of influence. We'll catch you on the next deep dive.